So today we are having this session for grade 11 as to discuss our answers for the study pack 1 that we have given for you during the holidays, right? So almost first 15 questions in that study pack paper 1 we have discussed. So today we are going to discuss with the second part of that, that is from 16th to 30th question. Hope every one of you have written the answers. Okay, let's go to the presentation. State the uses of the following instruments in laboratory experiments. First one, triple beam balance. What is the use of this balance? The function is then to measure the mass of the substances accurately. Volumetric flask. Volumetric flask we are using to measure the volume of liquids and also to prepare the solutions. Also to collect the liquids, we use this volumetric flask. And the third one, glass funnel. Glass funnel, in these laboratory activities, we are using as to filter and to transfer the solute to the volumetric flask. Volumetric flask is the place where we collect the way. So the solutes to transfer from the watch glass into the volumetric flask, to make it completely transferred into the volumetric flask, we are using these glass funnels, right? And the wash bottle. So what is the use of wash bottle? The use of wash bottle is to wash out the remaining solutes on the surface of volumetric flask and the wash glass. That means over the wash glass we are keeping the solute and also we are applying that into the funnel. These are the functions of these equipments. So we'll go to the next question. Number 17. State the methods used in the separation of components in a mixture and briefly define them. Number 1. Mechanical separation. The separation of components in a mixture using the difference of their physical properties such as density, particle size, particle shape, magnetic properties and electric properties is called mechanical separation. So what is this mechanical separation? Depending on the particle size, color, shape, magnetic properties, density, heaviness, we divide them, we separate them, right? And the second one, vaporization. During vaporization, the unnecessary components are vaporized by supplying heat to a mixture and essential components is isolated. Okay, and filtration. So filtration also you can see filtration can be used to separate from a mixture the components, right, that remain suspended in a liquid without going into the solution. That's the third one. Crystallization. Crystallization is the method of separating solid substances by concentration. When a solute that can turn into solid is present in a solution, just like we are producing salt as well as we are producing this sugar from molasses. So these are some examples, right? And recrystallization. The process of dissolving a solid crystalline substance and turning it again into crystals is called recrystallization. Recrystallization we apply as to obtain more purified standard quality solids. So there are differences between crystallization and recrystallization that are also given as a question there we will be discussing. Okay. And solvent extraction. Solvent extraction is the method of drawing up a substance from a solvent in which it is less soluble into another solvent in which it is more soluble. Where the two solvents are immiscible and are in contact with each other. You can remember the example. Iodine, we are extracting away from iodine solution into carbon tetrachloride. Simple distillation. There are three types of distillation. What we do here, we have to supply the heat, and there are two methods actually used in distillation. One is vaporization. Okay, the other one is condensation. Vaporization means liquid will be converted into gas by heating. Then the gases will be again converted into liquid, that is condensation. Alright. So what is the definition here? Simple distillation, it is used to separate components in a mixture which contains a volatile component with other non-volatile components. Simple distillation is only one volatile component is there. Volatile means we say which is having a lower boiling point which can quickly vaporize upon supplying heat. So accordingly only one volatile component is there we apply simple distillation. Then what is fractional distillation? Fractional distillation, there are many components which are volatile, but there is a difference between them. Okay, so what we do, they are one by one we extract them out under controlled cooling conditions, right? So you see there, separation of several components by distillation under controlled cooling conditions is known as fractional distillation. Remember, if there is a question regarding fractional distillation, definitely they will be asking what is the condition they have to apply here. The condition is between the components in the mixture, they should have a considerable difference. Okay, they should have a considerable difference between their volatilities. That means between their boiling points. If the boiling points are very closer to each other, we can't separate them out 100%. So crude oil refining as well as from air mixture, one by one the gases we are separating, like carbon dioxide, oxygen gases we can separate. That is also fractional distillation method. Steam distillation, distillation of a liquid in a current of steam, used specially to purify liquids that are not very volatile and are immiscible with water. These are not very volatile. So because of that, once we vaporize them, it cannot be separated out, extracted out. So what we do here, we apply them with water and we apply a current of steam, thereupon it will be vaporized and the vapors will be condensing them at the last, okay, that will be separated as two liquids because both the liquids are immiscible. Examples, different essential oils we are extracting from the plant parts. So we compare these three now. Simple distillation, only one volatile component is present with other non-volatile components. Fractional distillation, there are many volatile components where you have to extract one by one. There we use a fractionating column, and which is very much highly volatile will be vaporized from the upper part of the fractionating column, which is the lowest in volatility will be deposited down. And steam distillation, no volatile components present, so we apply them with water as to reduce their boiling point so we can vaporize them easily. And chromatography. So chromatography is the new technique applied here. You see what is there given. Chromatography is used to separate and identify the components present in a mixture, right? Solid or liquid containing non-volatile components. We can remember one example we discussed. Okay, separating out the components in chlorophyll. So depending on its solubility in the solvent as well as the attraction towards the mobile phase, there are two phases you could remember, mobile phase and stationary phase. Mobile phase is the solute to be moving upward, stationary phase is the paper, A4 papers or filter papers that we are using, chromatography papers. Alright. So now when the solvent is rising up, the solute that we have kept, which we want to separate, according to their attraction towards the mobile phase and the stationary phase, it will be rising up. So different attractions they will have, accordingly different heights they will be rising up, so we can separate them out. So this is chromatography. So accordingly, what are the methods that we have discussed now? Mechanical separation, vaporization, filtration, all right, crystallization, recrystallization, solvent extraction, simple distillation, fractional distillation, steam distillation, and chromatography. There are 10 physical methods that we have learned. The next question is, give 3 examples of mechanical separation. Winnowing, sieving, sifting, magnetic separation, floating on water, and number 19. Mention the difference between crystallization and recrystallization. In crystallization, a solid is dissolved in a hot solvent until it becomes saturated and vaporized to increase the concentration, and thereby the solid is obtained. In a hot solvent, the solid will be dissolved. Until it is saturated, we have to keep it there and we have to vaporize. After that, only we obtain the solid. But when it comes to recrystallization, first we dissolve in a hot solvent. Okay, they will be getting saturated. After that, we have to filter it. Filtering, then we have to go for cooling them down. We have to condense them down. Now, being condensed, it will be saturated to obtain a very much more purified solid crystal. You see the difference here, right? It is a hot solvent, straightly will be saturated and thereby we will be getting the solvent. But here, first it will be saturated in a hot solvent, then we have to filter the solute and we have to cool it down. Again, we have to saturate in that cold solvent. So, and the second example. In crystallization, the solid is obtained from a hot solvent, whereas the recrystallization, the solid is obtained from cold solvent. That's correct, right? And the third one, the solids obtained from recrystallization are more pure and standard than that of obtained by crystallization. So let's go to the next question. Number 20. Mention the difference between simple distillation and fractional distillation. So what is the difference between them? In simple distillation, only one volatile component is separated from other non-volatile components. We said that earlier, right? But in fractional distillation, several components are separated from the mixture by distillation under controlled cooling conditions. So number 21. Give an instance where the fractional distillation is used. So fractional distillation, we said there are many volatile components. We have one by one, we have to separate them out. So what are they? Refining of crude oil, right? This petrol, diesel, tar, everything we are separating out from crude oil. That is fractional distillation, and also gaseous air separation. And number 22. Give 5 examples for essential oils. So what are called essential oils here? there are some plants where they do contain volatile components which could be vaporized out. So these volatile compounds are what we are obtaining from the plant parts. Okay, so these are what we term as essential oils. Accordingly, what is the definition for that? The volatile components, okay, obtained from the plant parts are what we name as essential oils: cinnamon bark oil, cinnamon leaf oil, citronella oil, nutmeg oil, pepper oil, cardamom oil, and eucalyptus oil. So these are few examples. So next we are coming for question number 23. State the methods used in extraction of essential oils from plants. So there are three methods used: steam distillation, solvent extraction, compression under high pressure. Number 24. State the methods used in extraction of salt from seawater. The place that we are using, the manufacturing site, we are naming as a SALTERN. Alright. So what are the methods that we are using? There are two steps that we are using here. First, we have to vaporize, and then second one, crystallization. So actually, concentration is what we are doing here. We concentrate, we increase the concentration of the solute by vaporization and crystallization. So vaporization and crystallization are the answers here. Number 25. What are the factors which are considered when choosing a place for a salter? You could remember, when we are having a salter, that should not be a place which is far away from sea. It should be a flat land situated closer to a coastal area to obtain seawater easily. And presence of a clay soil with minimum percolation of water, minimum amount of soil water. Okay, it should not be having higher amount of soil water. And prevalence of dry and hot climate with bright sunlight and wind throughout the year. Throughout the year, it should be having a dry and hot climatic condition. It should be having a bright sun. A dry wind should be there throughout the year. And also, annual rainfall should be at a minimum level. So these are the factors that we have to consider when we are choosing a place for a salter. Number 26. Name the types of tanks found in a salter. So there are three types of tanks. What are the three types of tanks? Shallow tank, or we say large tank, and then the medium tank and the small tank. So these are the three types of tank found in a salter. One by one, connected to, we have to transfer the water, the sea water that we are getting. So very first, in large shallow tank, we have to obtain this water. From that shallow tank to medium, medium to small, we have to transfer, and we increase the concentration step by step. There will be components being deposited, and at last there will be sodium chloride, which we say as a salt we obtain. Number 27. When common salt is exposed to air, it gets wet. Explain the reason. Now, this common salt or sodium chloride, when we are keeping it exposed to air, it is getting wet. What is the reason for this? Can you remember, in the small tank, not only sodium chloride is precipitated down. Along with sodium chloride, there are two other components also precipitated. That is magnesium chloride and magnesium sulfate. So this common salt alone, when you take, okay, that is not hygroscopic. That won't be absorbing water. But when it comes connected with magnesium chloride, it can absorb moisture, water from atmosphere. So due to this, magnesium chloride present with salt, it absorbs water, and the common salt becomes wet. It gets wet when it is exposed to air. So that is the answer here. 28. What are the byproducts of salt industry? So salt is the main product. What are the byproducts? There are two byproducts. We name them as gypsum and plaster of Paris. Number 29. How is iodized salt produced? People have heard of these. Not only common salt, there is iodized salt and table salt too. What is this iodized salt? You see here. How do you define? Iodized salt is produced by adding potassium iodate, KiO3. Potassium iodate, KiO3. That is what we are mixing up, but there is a standard. What is it? In the preparation of iodized salt, 40 to 50 milligrams of potassium iodate is added for 1 kilogram of salt. This is the way we prepare iodized salt. Okay, so the very last question we are coming for: how is table salt produced? Table salt is produced by passing hydrochloric acid vapor through concentrated solution of sodium chloride. So sodium chloride at a high concentration, through these we have to pass hydrochloric acid, HCl acid. HCl acid not as a liquid, as a vapor, vaporized gaseous vapors, we have to pass them so we can produce table salt. So these are the second 15 questions that we are discussing under the study pack number 1. So hope you all have understood. So completely we have done with that, and if you couldn't get the access for the earlier 15 questions, still you can log into the video in our YouTube channel. So that is there with the topic. Okay, all the videos we are updating there. You can access that anytime whenever you are having the questions.
To get notified about our next videos, subscribe to our YouTube channel Science with Anas Mohideen.